Okay, good afternoon, guys. Today we'll discuss about Bezier curve, which comes in module 5. So, before talking about Bezier curve, let us understand how exactly computer draws any curve. For example, in my previous sessions, whenever we draw a line, we understood how exactly it draws the line. So the courtesy is Bresnan, and then we understood how exactly it draws a circle. Again, the courtesy is midpoint line or Bresnan's, midpoint circle or Bresnan's circle algorithm. So like this, there is this curve, right? There is this curve, and yeah, so you can restructure your curve, or basically, if I ask you a question, how exactly computer draws any curve, so what is the answer, or what algorithm it follows? So well, the answer is today's class, that is Bezier curve. Now, to understand how exactly computer draws any curve, one of the logic, or the Bezier curves logic, can be understood by something like this. So what you do is, consider a straight line like this, and consider one more line, perhaps something like this, and what you do is consider one more line, let us say green color line. What you do is start from the first point of the first line and join the first point of the second line. I'll repeat. What I did is I had two blue color lines, and what I did is I took one green color line. I joined the first point of the first line to the first point of the second line. And then what I'll do is I'll take, let us say, a black color pencil, and I'll mark the first point like this. So this is my first point. Now what we will essentially do is we will move this green color line along with the first line, along with the second line. So imagine the green color line is just getting moved from the first line, and this also is getting moved along with the second line. So what really happens is, as and when you move linearly, you will start getting a nice curve like this. To understand this in a better way, you can just go to this. So look at this. We have two blue color lines, and what I'll do is I'll take one green color line, join the first point of the first line and the first point of the second line. That is your green color line, and this is your black point, whatever I told you. Now essentially what you need to do is move this green color line along with this first line and the second line. So what really happens now, as and when you move linearly, is something like this. So just move the green color line. You can now see the black point just linearly moves. You can see, as and when you move this green color line, which is nothing but the joining line between the first point of the first line and the first point of the second line. So if you just move, you can see this black color follows this green color. So this is how computer understands the curve. Now this is nothing but a parametric equation. You can see how many points we have. We have 2 points, and we have two lines here. So that is how you will get a curve like this. And Perhaps you can see, yeah, this is done. And you can increase the number of blue color lines. Example, you can see here, there comes three blue color lines, one here, second line, third line. And what you do, take two green color lines. So that means join the first point of the first blue color with the first point of the second blue color line. Also, first point of the second blue color line join with the first point of the third blue color line. That is your green color. And again, you can take one more pink color line which joins the first point of the green color with the first point of the green color's second line. So now if you move this pink color line now, you can now see as and when you move the pink color line linearly, the blue color follows the pink color line. So this is how a curve gets generated. All right, I'll pause it here. You can see here there are three blue color lines. First is you should draw the green color line. So green color line means the first point of the blue color to the first point of the second line, blue color. And there is one more green color, the first point of the second green color, second blue color, and the first point of the third blue color. And there is a pink line. What you should do is first point of the green color line of the first line, first green line, and you should join to the first point of the second green color. There exactly you get pink color. Now you move the pink color line. Basically you mark a black colored dot in the pink line, and you move the pink line. As and when you move the pink line, you will get a curve like this. Okay, you can see here, I'll show here. Yeah, this is what I spoke about. Three blues, two greens, one pink. So you move the pink line. As and when the pink follows the green line, the curve gets generated. This is third order parametric equation. Now you can increase the number of blue color lines. Thus you will also increase the green colors. Thus also will increase pink color, any other color. Means keep joining the first point of the conjoint line with the second point with the first point of the next line. So follow it, you will get a curve like this. So you can increase, you can have your own shapes of your blue colors. That is how you will get it. You can see, So this is how I can make you understand the fundamentals of any curve. Now coming specifically to the one second. So just say Bezier curve. Just go to wiki. All right. So go here. Yeah, you can see in wiki we have they have given this nice GIF images. You can see there are two lines, and the green color is the joining line, and the red one is the curve. You can see how exactly it animates. And increase the number of lines, you will get a curve like this, and increase again the fourth order. This is the fourth order curves, and this is the third order, and this is the first order. First order means one line, and you cannot have the green color line because there's only one line, and if you follow it, you will get a straight line. And if you increase the number of lines, that is here we have only one line, and here we have two lines, and you have one more green color line joining the first point of the first line to the first point of the second line. And as and when you increase, as and when you traverse, you can see the curve getting formed. So moving on to the next piece of information, You can see here, yeah. Bezier curves are nothing but parametric curves that are generated with control points. What do you mean by control points is these are the points, P0, P1, P2. You can see, I'll just show this. You can see here, yeah, there are various ways. So quadratic Bezier curves, cubic Bezier curves, uh, this is the second order, this is the third order. So more number of control, this we call P0, P1, P2, P3 as control points. So if the more is the control point, more smoothness in your curves. If you have less control points, for example, if you have only P0, P1, only one line, you will not at all get a curve. You will not at all get a curve. You will get a straight line, something like this. I showed here. Yeah, P0, P1, only two control points. You will get a straight line. P0, P1, P2, three control points. You will get a curve like this. If you want more smoothness, increase the control points. That means more curviness. Keep on increasing the control points. You can see more the control points, more is the smoothness, or more is the curviness, I can say. Now coming to the next point, you can see, you can just read this. The t is the function, that is this t. You can see t is getting incremented here. T is equal to from 0 to 1. So t is a function of linear Bezier curve, can be thought as describing P0 to P1. So when t is equal to 0.25, that is, see, t starts from 0, 0, 0 0.1, 0.2, 0.3, 0.4 up to 1. So when t is at 0.25, you can see the curve has traversed 1/4. You can see when t is at 1, the curve is full here. When t is 0.5, the curve is half. So basically the time function traverses from 0 to 1, and the more the number of control points, the better the curve looks like. And of course, t always ranges from 0 to 1. All right. So this is the second basics that I can say. Now moving on to the more specific Bezier curve nature. Bezier curves are parametric curves that are generated with control points. Control points mean that's P0, P1, P2. It is widely used in computer graphics and other industry as they appear reasonably smooth at all scales. Bezier curves gets the name from the French engineer Pierre Bezier, who discovered it. Now, all this while we talked about how exactly computer understands Bezier curve, but Bezier curves mathematics is something like this. We have what is called as Bernstein polynomial. Bernstein polynomial means it is NCI 1 minus t to the power n minus t into t to the power I. T ranges from 0 to 1. I told you here. Any doubts? Means you can put here. All right. So t ranges from 0 to 1. That is this t. Yeah, t ranges from 0 to 1, and this this equation is called as Bernstein polynomial. That is Bernstein polynomial. Now what you have to do is multiply Bernstein polynomial. That is multiply this for all the points. I am now talking about the summation of k is equal to 0 to n. 0 to n means how many ever iterations you want. P is your control points, and you have to multiply this control points with your Bernstein polynomial. So essentially what you need, where n is the polynomial degree, I is the index, and t is a variable. This I'll talk more about this in a couple of minutes. Now Bezier curves are of different degree, linear curve, quadratic curve, cubic curve, whatever I showed you now. Now essentially what you need to do is Bezier curve is equal to Bernstein polynomial, that is this, into for every point. You can see pi into bi to the power, bin of t. So bin t of t is this, that is what we call as Bernstein polynomial, this into p. So essentially what you need to do is Bezier curve is equal to Bernstein polynomial, the entire thing, into for every point, pi. So Bezier curve is equal to Bernstein polynomial means this, nci 1 minus t n to the power n minus t. This is the parametric equation into for every point, where n is equal to number of control points. So here we have 3 control points. We have here we have 1, 2, 3, 4 control points. So n is equal to number of control points minus 1. This is your n, where n is equal to, the formula is number of control. What is n? This n. I'm talking about this n. This n. N ci 1 minus t to the power n minus t. So that is number of control points minus 1. T ranges from 0 to 1, as I already talked. So the basic flow is, first, how do you make the machine understand now? First, you need to calculate NCR, that is compute NCR. Next is, you should calculate this guy, 1 minus t to the power n minus t into t to the power of I, that is the parametric Bernstein polynomial. And then multiply all these for every point. Finally, multiply all. So this is how you'll get it. Now, anyway, let us start from the beginning. Before this, we will apply Bezier curve and to simulate, the Indian flag. So let me show the output now. Any doubts means please let me know here. All right. All right. So this is the lab program number 8. Program, develop a program. Menu driven is not there. It's just a program to animate a flag using Bezier curve. Now, what do you mean by Bezier curve? We understood, and how exactly we can get a flag. That is what we will try to understand now. So, the moment you run this program, you will see that this is what you'll see. You'll see the Indian flag nicely getting animated. But what do you think this saffron curve, white, and the green curve? What do you think it is made up of? Now, the answer is, I will talk about the answer via my code itself. To repeat, this is the output. Okay, how do we get it? We will understand in a bit. So what I'll do is essentially copy this, put it here, start buffers, and give me the control, the breakpoint here, and debug it. So yeah, now I will press run to cursor. All right, you can now see here we got one thread of my saffron color. So don't you think this is a Bezier curve? This is a curve. Of course, this is a curve, and it is getting generated via my Bezier curve, Bezier's equation. So what I'm trying to say you is, Indian flag is not getting generated in one shot. So you can see my for loop here. For I is equal to 0 to 50, that means 50 times I am now generating a saffron Bezier curve. Now again, I'll press this run to cursor. So you can see in the output here. So 50 times, so I'm just appending it. I'm appending 50 times. Run to cursor is F4. All right. So 50 times if I run it, I will get saffron uh, saffron portion. Okay. And next is like this. The control comes here. Okay, I didn't do. You should have pressed it. So what I'll do is I have. So this is how you will get saffron color. Now what you can do is, perhaps you can press the breakpoint here and debug it. So you will notice 50 times my control would have ran here. So now I am in the white color, that is 111. Now if I do debug, if I do run to cursor, you can see one white color curve has been generated. You can see like this 50 times. So 50 Bezier curves getting appended because I'm using this translate. So every time you generate a new curve, translate it. It means just go down. You can see here, xy is 0, zy is 0. Only y is, that is minus. Minus 0.8 means just come down. If you give me plus 0.8, I will go up. So I will come from the top to the bottom. That is why I'm using minus. Now if I keep on pressing this, so 50 times I get white color, and next is the green color. So what I'll do is keep the breakpoint perhaps here, and debug it. So you can see 50 times of saffron curves is done, 50 times of white is done. Now comes green color. So RBG, R, red, green, blue. Yeah, RGB. Red is 0, green is 1, and blue is 0. So now you press run to cursor. You can see one green curve like this. Keep pressing F4. 50 times green color comes. 50 times green color, and after 50 times I need to essentially draw a pole. So what do you mean by a pole? You can see here. Yeah, so 50 times green color. Once you're done, essentially pole is nothing but line, but what I'm cleverly doing is I'm increasing the line width. So if this is, that is 5, now I can make it as 20, and what I'll do is perhaps I'll put it here. So now debug it. So all my 50, everything is done. So only post is left. That is the pole. Pole is left. So pole is nothing but of line size 20, and I'm just writing a line from 100, 400 to 140. Um, just go to next line. You can see a nice pole here. No Ashoka Chakra here, of course. I mean, last year we thought it would be too difficult for students to write the 24 spokes and all. So anyway, you're free. This is not a complete Indian flag. Let me accept it. So your guys, I rather wish or rather request you guys to come out with nice circle with 24 spokes. Ashoka Chakra. You can nicely put it to the center of the white color curves. Now this is the application of Bezier curves. So we can make an Indian flag, and animation has got nothing to do with Bezier curves. So we will now animate it in a different way that I'll talk now. All right. So now that we have understood Bezier curve via the paint, via the PPT, via the video, as well as the PDF and the wiki as well. So now we'll use Bezier curves to understand the program. All right. So now go to my manual. You will see I have extensively written eighth program notes. All right. So this is what we saw, and essentially Bezier curve means NCR into this for every point. That is what we need to do. All right. Now let us come from the main program. All right. Before main, do we have any global functions? We'll see. Yeah, only we have theta. Pi we have 3.14 and theta is 0 degree. That means essentially right now we are not animating it. Theta is equal to 0 degree means we are not animating it. So these are all the various functions will come as and when we call them. So we'll start with main. Anyway, init is projected, load the identity matrix, and ortho 2D. This is not a 3D 3D program. This is just a 2D. And why we require matrix mode projection and load entity is every time we get a curve, we need to animate it. Animate means of course some translation will happen, and we need to multiply the model view matrix and everything. So and again you have to project it the new animated curve. So that is the reason you are doing it. And why are you going behind ortho 2D? Because we are only displaying a 2D Indian flag. All right. So why this is done? Because there are more swap buffers, right? Okay. Yeah, this one. All right. Yeah, you can see here nice flag. All right. So we saw the program. Now come to the main function. This is the initialization of the graphics, and we are using double buffering. Why? Because we use swap buffers here. All right, because it is getting changed. Yeah, we are loading the identity, and RGB and init window position is 00. Window size is 500, and basic whatever, and call init. So all my camera will be set, and then call display. Now in display, this is my display. All right. Now color buffer bit. So what have you set? Have you set any color? No. So that's the reason this is black color. So by default, black color. All right. So that is done. Okay. Now here comes the main part. So number of control points is 4, but number of Bezier points is 20. How will I make you understand is, I have a plan. Look here. All right. Now, if you make 4 as 2, you will see something like this. All right. Now, let me make this as 4. 4 control points. I told you more is the number of control points. It is better. And of course, the Bezier points means, I forgot to tell you about this. Yeah, you can see the way this black color follows, the way this black point follows, those are your Bezier curves. Now, of course, the more is the Bezier points, the better is the smoothness. Now, for example, for convenience sake, let us take this as 4. Number of Bezier points as 4. If you debug, you will see something like this: 1, 2, 3, 4. 4 Bezier points. That is, the transition is not smooth because you're allowing me to have only 4 Bezier point. That is the intermediate points. Now what I'll do is I'll make this 4 as 40 now. Run it. You can see more smoothness because if you look here, you can see more smoothness here because there are more points. You're allowing me to have more points. Similarly, if you come out with, let us say, 2, that means you're allowing me only 2 points. You can see 2 points, so it looks like a static one. So the more realisticness, you make sure you increase this. All right, this also you can increase. You can make this as 6, and you can see the number of floating points here. So it has gone, it doesn't understand 6 points. Why? Because here I am saying here points array of 4. That means I'm taking only 4 points here. If you take 6, make sure you increase this. That means for every point x, y, z, here I am taking 6 means you should add another couple of points here. So that is the reason it gives this kinds of output. Why? Because I have only 4 set of points, and now you are asking me to give 6, which I have not defined here. So you define it equivalently, you'll get it. So the understanding is number of control points 4 means, so you need to have 4 set of points. Bezier points, you need not have to worry. You can, if you decrease this guy, you will see not a animated, not a smooth curve. You increase this, you will get the smooth curve. All right. Now third line, since we have 4 control points, you need to define xyz of every control point. And because it is a 2D diagram, 2D output, my z coordinate always remains same. I mean, always remains 0. So that is the reason z is remaining as 0. All right. Now, control points x and y, I am defining it. You need not have to mug these values. Just keep trying your coordinate system until you see the control points neatly situated. So you need not have to mug this. So 100 400 is one control point. What do you mean by control point? This what I'm saying is this. So I am taking 4 control points: p0, p1, p2, p3. So p0's xyz is this: 100 comma 400 comma 0. p1's xyz is 100 comma 150 comma 450 comma 0. The 2D output. That is the reason I'm taking 0. Z axis as 0. All right. So we have 4 control points. So every control point has xyz. That is the reason I am saying this. So if you can increase 1, 2, 3, 4, 5. There are 5 control points. So you can add one more set of uh, the coordinate system. So because I have 4, y4 means my wish. I have this purely my wish. I have taken 4. You can increase it or decrease it. If you can increase it, write the corresponding coordinates. All right. So next, for this part is for your animation. This will give you one flag, but to animate it, you need to change for every control point, change your x and y, x and y, x and y, such that it animates. You can see here 50 into, because it's animation, so follow this process. Say sine into, you are converting basically degrees into radians. So theta into pi by 180, 50. Just change these guys, 50, 25, 50, 25. So this is plus, this is minus, this is minus plus. Of course, if you don't do this, let us say, let me comment out this, you can see there will be a change in the animation. So if you don't, if you don't do this at all, you can see you will get a flag. Bezier curve, of course, will give you a flag, but you're not animating it. So animating means what? It's like going, back and forth. So going back means it is minus, going forth means it is plus. So these are those guys. You can see this is minus, this is minus, this is plus. So these are the various back and forth mechanism that we have done only to just to change the control points position. See, control points position was 100 comma 400 statically, but how do you keep on changing from, let's say, I want to make this as 99 and I want to make this as 399. Next time I want to make this as 101, I want to make this as 401. Next time I want to make this as 98, 402. So instead of making that, what I'll do is I'll take one array. Anyway, I have an array. So I'll just do some mathematics. I'll increment a bit, I'll decrement a bit. So 50 times you can, of course, 50, 25 is your coefficient. If you can make this as, let us say, 5, and this instead of 25 into 2, you can just see how exactly it animates. And of course, for every value, uh, you may not see the reflection in your output, because 50 into that, 25 into that, and getting converted to 5 into and 2 into, may it is making a difference, but for our eyes we may not see it. So that's the reason I told you not to mug these values. Just come out with your own values. Just increment. I mean, just change the values. You will understand the basicsness. But the point is, these 6 guys are purely for animation. And you can see here the global value theta is 0 initially, and as and when you want to multiply, I mean, as and when you do animation, 2 degrees I will animate, because sine 0 by this initially, next sine 2 by this, 4 by this, 6 by this, 8, 10, it just goes on. It just goes on. Push matrix, before you animate, push the current state, and then you animate, and then pop the matrix. You can see pop the matrix, so that you will see the initial state, the change state simultaneously. We saw this neatly in our teapot program. So point size is 5. Why? Because let me show here. So you will draw a curve like this. What is the point size for every base, every point? So that is your 5. My wish. Okay, first one, what you need to do is, first is all saffron color. So saffron color's code is 100% of red, 40% of green, 20% of blue. So if you mix all these, you will get apparently saffron color. And this I already talked. So 50 curves you need to generate. You need to generate one curve. So this function will generate one saf, or I can say one curve. So I wanna have 50 curves like this. So every curve you should, I can say, after, sorry, after one curve The second curve should come below it, right? So below it. So it goes on. So below it means x wise I'm not changing it, z wise I'm not changing it. So only y wise below minus 0.8. So what happens if you do plus 0.8? Run it, you can see is after one curve I am just going up. So that is the reason you can see only one saffron thread here. So that should be minus. That is the reason you will get one curve, below that one curve, the second one, below that third one, it goes on. Now you can ask me one question, why this is x0, z0? Because we are not changing the horizontalness, only verticalness. But if you make this as 0.8, so the second curve moves xwise. And if you can change this also x to uh, point z also to point as 0.8, so x is also getting moved and y is also getting moved. So I am not bothered about x and z, I am only bothered about y. So horizontalness, I believe you understood. All right. So yeah, this is translation, and this is our main discussion, Bezier curve. So I'll call a function called Bezier, and I am passing control points array, means this array, number of control points, that is your 4, number of Bezier points, that is your 30, 20, 40, whatever. So now let us go to Bezier. Now I am coming to Bezier. So because I am passing this as an array, this is an array, how do I take it in my calling function? Of course I should make this as a pointer. If you don't make this as a pointer, what happens? If you don't make this as a pointer, you change, because you're basically changing here, you're changing here, and for the caller it will not be reflected. The one who is calling, display function is calling Bezier, and you are passing an array, and you don't make this as a pointer, whatever the callee makes changes, the caller will not get changed. So that's the reason, because it's an array. Because it's an array, you make this as pointer. All right. So control points array, everything will get number of control points 4, number of Bezier points 20, 30, whatever. Now point I am making as a type def. You can see, yeah, I'm making as a structure basically. You can go with type def as well, no problem. So point is a structure having xyz. So that variable I have one actual Bezier point. Actual Bezier point means yeah, this black color dot. I am saying you 30 Bezier points, but the actual Bezier point is that black color, the black color point which follows. So initially that black color point I need to have as a point one, which apparently has x comma y comma z. All are junk. All are junk basically. So float t, I told you t should range from 0 to 1 in all the curves. So 0 to 1, 0 to 1, 0 to 1. So initially, yeah, I need to have the t, and you need to hold your NCR values. Why? Because you can see in my PDF, you will basically generate NCR, but you will generate NCR and to this for every point, right? So I should have one NCR values which holds all my NCR computations. So that's the reason I am having NCR. Okay, better I'll explain here itself. Yeah, here. So hold NCR, that's also a pointer, and for iteration I have I. So hold NCR values, this is this variable. What I'm doing is, how many NCR values I should have? Number of control points. So that is 4. Now essentially what I should do, I should calculate this. N is equal to number of control points minus 1. So that is what I'll do now. Yeah, number of control points minus 1, that is your N. Okay, let me show this as well as this. Okay, okay. So now hold NCR, that is hold NCR is it is 4 now. Number of control points is 4. Now compute NCR, that is I should calculate this number of control points minus 1, that is your n is always number of control points minus 1, that is 4 minus 1 3. So n should be 3. How will I get 3 from 4? So I will do this number of control points, that is 4 minus 1 3. So the values that you pass is 4 minus 1, that is 3 comma old NCR values. So this is the pointer you are passing it. All this is your pointer to old NCR base. Old NCRs. All right. So now you are calling compute NCR. Compute NCR is a simple function. It's a factorial function. NCR, of course, NCR is what? N factorial divided by n minus r factorial into r factorial. All right. So that is what we will do now. So you are actually calling compute NCR with 2 parameters. I will collect it in 2 parameters. R is equal to 0 to n, that is starting from nc0, nc1, nc2, nc3 till ncn, that is 4c0, 4c1, 4c2, 4c3, 4c4. Hold NCR R is equal to this, you know, right? Factorial n, I mean, NCR is nothing but n factorial by n minus r factorial into r factorial. What is factorial function? You this anyway, you know. Factorial, this is a recursive function. The moment n becomes equal to 1, return the 1, else n into n factorial of n minus 1. So this is your second semester CCP thing, and this is also your second semester, guys. So this is NCR calculation. This guy is calling factorial. Factorial is this. So ultimately, what happens is the moment you call compute NCR, ultimately in your hold NCR values, can you tell me what it holds? It basically holds 4C0 value, 4C1 value, 4C2 up to 4C0 up to up to 4C4 values. So this is this will be held in old NCR. Make sure, I mean, you notice this is an array. This is an array. So NC0, it will be in the 0th position. NC, I mean 4C0, it will be in the 0th position. 4C1 will be in the first position. It's a single dimension array. All right. So that means I am done with my NCR values. Means I am done with this NCR part. So the next part is what? This 1 minus t into, I mean, to the power of n minus t into t to the power of 5. That is what I need to calculate. All right. So compute NCR is done. Line strip. That is your, what is line strip? Here. Where's paint? Yeah. Line strip is what? What is line loop? This is, I mean, yeah. This is one line, second line, third line. This is your line strip. Fourth, I mean, line loop is closing the fourth and the third one. I mean, the first one. So line strip is first, second, third. Don't, I mean, join it. So don't join the first and the last. That is your line strip. All right. So the curve is a line strip basically, and now we will make it as a curve from line strip to curve. All right. So now for I is equal to 0 to number of Bezier points, you can see number of Bezier points is 30. So for I is equal to I ranges from sorry, I ranges from 0 to 30. P is equal to, I told you in my wiki class, wiki section, T always ranges from 0 to 1. So 0 to 1, 0 to 1. So yeah, T is equal to I, that is, I is 0 now, 0 divided by, everything is float, I 0 by number of Bezier points is 30. So 0 by 30 is equal to 0. Next iteration, I gets incremented. It is 1 by 30, which is equal to, let us say, some point 0.05 or whatever. Next one, 2 divided by 30, some value, 3 by 30, 4 by 30, up to less than Bezier point, means up to here, up to it is 30 by 30, which is equal to 1. So means, so t is ranging from 0 to 1, which we saw in wiki, 0 to 1, 0 to 1. All right. So t right now value is 0 by 30, that is the 0. Compute Bezier point. That means you should essentially calculate this first black color point. Once you're done, go with the second black color point. Like this, finish it off. All right. So compute Bezier points means to say I should essentially do this guy, 1 minus t, this guy. All right. Compute Bezier points. Now I'm passing 5 points here. That is t, that is 0. Okay, let me write here. I'm passing t, that is 0. Okay. Second one, the address of actual Bezier point. See, actual Bezier point, that is the first black point. First black point's address. I will write it as address of first black point. Okay. Why am I sending address? If you don't send address, because I'm sending address, this guy is using pointer. If you don't send address, this guy will not, you will not use pointer, and whatever you make the change here, this caller will not get to know, will not be reflected. So that's the reason you're passing the address. Third parameter is number of control points. Number of control points we know as 4. So the third parameter is you're sending 4. Next one, control points array. That is your house. Control points, these guys for animation part. So I can say for animation guys. Next one, fifth one, hold NCR values. That is your these guys. So that means this 4C0 up to 4C4. That is the entire array of 4C0 to. So these 5 parameters you will send in your compute Bezier points. So now go to compute Bezier points. Take this, use the same thing. I is okay, n is equal to number of control points minus 1. Why? Because I have written here n is equal to number of control points minus 1. 4 minus 1, 3. So your n will now be 4 minus 1, which is equal to 3. Bernstein polynomial. What is Bernstein polynomial? This guy. The entire thing, NCR into this fellow, the parametric equation. Now, but the point is NCR we know. NCR we know how? The hold NCR guys. Hold NCR values is there in my NCR. I mean, this NCR is there in my hold NCR values. Into this, what I should do. All right. So Bernstein polynomial. Now actual Bezier points. You remember I had written. One second. Actual Bezier point, that is the actual black point, has XYZ, but where exactly XYZ starts, let me make that as 0, 0, 0. So I can write the comment here. Actual black point points coordinates is equal to 0, 0, 0. Anyway, Z is anyway 0. So X is 0, Y is 0, Z is 0. Okay. Now for I is equal to 0 to control points. That means 0 to control points is 4. That means 0, 1, 2, 3. So 4 times, because you're using this 0, 1, 2, 3. That is 4 control points. What you should calculate? Bernstein polynomial. You can please side by side. You can look this, please. Yeah. All right. Okay. Bernstein polynomial. That is this entire this NCR into this. Bernstein polynomial is hold NCR values of I. That is 4C0. 4C0 into this is what I should do. So 1 minus t, you can see here 1 minus t to the power, I am using a power function, 1 minus t into what? N minus t, n minus t to the power into t to the power I, into t to the power I. All right. So 1 minus t into 1 minus t is your 1 minus t is here to the power. It should be 1 second. It should be n minus t. It should be n minus t. No, it should be n minus I. Okay, because I ranges from 0 to, because I ranges from here. Yeah, here. I ranges from 0 to 1. That is the reason I am taking n minus I. So this is your n minus I. All right. So next one. I now got to know about my Bernstein polynomial here. This is my Bernstein polynomial. Now what is the next thing that is left? I should multiply this for every point, for every Bezier point. So Bezier point of x is equal to plus Bernstein polynomial into control points array of x. That is, actual Bezier point of x is equal to this Bernstein polynomial into control point, that is the first control point, that is your p0, here, p0 of x. Next, similarly, you should do this for y. Actual Bezier point of y is equal to Bernstein polynomial into p naught of y. You can skip this guy. The third line you can skip anywhere. This is 0. This is also 0. You can skip it. So you should do this for 4 control points. So if you do this for one shot, if you do this, that means you're done with p naught. Like this, we have p naught, p1, p2, p3. So we have 4 control points. So 0 to 4, that is 0, 1, 2, 3. You should do this. Now this will finish your compute Bezier point. Compute Bezier points. Now, who is calling it? Compute Bezier points. Whatever we did, who is calling? Bezier curve is calling in where for I is equal to 0 to 30. 30 times, that is between p0 to p1. Because anyway, the curve is 30. 30 times I should plot my black color points. So it is being done here. 30 times compute Bezier points will be done for what? Who is calling it? Yeah, who is calling it? Bezier, guys. Bezier. And who is calling Bezier? Who is calling Bezier? Display. So 30 times you need to call Bezier. I mean, one time if you call Bezier, it will now give me 30 points for all the NCRs. Like this, you need to call 50 times, because one curve, one saffron curve, you are calling like this, Bezier, and it is in turn calculating for all the Bezier points, for all the here, for all the control points. So you can calculate, you can multiply 50 into 30 into 4. So those many iterations will be done for one simple curve. That is how, guys, that is how, you can see here. Yeah, here. That is how a line strip gets converted to a curve. Simply put, you draw a line, how exactly you can change this. For example, you draw a line, and how exactly you can change this. See, if you keep on doing this 30 times, 50 times and all, you can change these. You can convert your line strip to curve. That is what all these calculations are doing basically. All right. So simple recap I'll do. We came from main, we called display. So we went to display. We are done with animation. Saffron color, one color we called Bezier, and this Bezier for 30 Bezier points, it called compute Bezier points. Compute Bezier points 4 times, that is for 4 control points, it calculated this, and it came back for 30 times. This happened, and Bezier is done, and then it will now come to this flower bracket. And again, for the second curve, translate a bit, call Bezier. So Bezier means, again, I mean, if you, again, same thing, for 30 control points, you should call compute Bezier points. In turn, it calculates for 4 control points. So don't get confused between Bezier points and control points. I'll clarify here. Control points are your P0, P1, P2, P3, 4 control points. Bezier points are your this black color dots, black dots. Every black dot, for example, let me show here. Basically, you will draw some blue lines, right? And then you will draw this line, right? And then the black point is this point. Black point is this point. Now this is initially at 0, 0, 0, as and when you move this green line along with the second line, this black color line will now come here. If you move again green color line, this black will come here. Again the black point comes here. So look here, this is P0, P1, this is also P1, P2. You can see these are your control points, P0, P1, P2. You can have as much as lines you want. These are all various control points, P3, 4 control points. But what do you mean by Bezier points? These are your Bezier points, the black color which follows. Sorry, it should not write like this. So it follows something like this. As and when you move the green color, it follows, right? Remember, I had given a I showed a video, right? So you can see here, yeah, this one. We had blue lines, yeah, the black flows, yeah. These are the 20 or 30 Bezier points. So control points are 1, 2, 3, and it can have 20, 30 Bezier points. So understand like this: the black guys are Beziers, and the blue guys are your control points. All right. What is left? So yeah, 50 times you call Bezier. Once that is done, change the color, saffron white 50 times again. Same function. Green same function, and pop matrix, get the initial and the final. Whole line width, I already talked to you. A line from a thick line, basically 20 width, thick line from 100, 400 to 140. And post redisplay, don't make the main function to call display again and again. You only, you in the sense you are in display. Let the display only call the display function again and again. Swap buffers, why? Because we are using double buffer. Every time you post redisplay, every time you project it, keep on swapping the buffers. So this concludes display. Anything left? And once you are done, you release your memory, because compute Bezier points are anyway done. You should release your hold NCR values for the next one, for the next iteration. So compute Bezier is done, NCR is done, factorial is done, point is done. All right. So this is how basically you will get an animated flag. Animation courtesy is these, yeah, 6 plus 7 lines. Animation courtesy is this 7 lines. All right, yeah, you need not have to worry about 50, 25, all these. These are all pure trial and error, guys. Only thing you should worry is your mathematics. Mathematics should be proper. So if you understand, I mean, basically you need to multiply all these, that's it. So it all depends on the programming, how exactly we should take care about. Okay, let me tell you from the student's angle. You should take care about these guys, small control points of array of I into X, and this plus, from a student's perspective I'm talking. So, and then this as well, 50 times, we call this, make sure T is ranging from 0 to 1. So subtle, small subtle issues you need to, basically this is nothing but pure mathematics. So take care about these subtle things. And my main my main intention is to teach you this mathematics. So I believe that is done. So all in all, Bezier curves, parametric curves generated with control points. You can imagine, a kid holding, two sticks, and you can make a curve, right? You can just move your sticks a bit, and you can nicely, you can have a thread, and place it on the first point of the first stick and the first point of the second stick. So the move your sticks around, thus you will get a nice curve. That's the motivation behind this mathematics. And this mathematics is nothing but, this is the way to make your machine understand as well. So any doubts, you can please post it here. Any doubts, guys? Have you understood basically? Can I get a reply? Have you understood first question? Yes. So any doubts? Yeah, thank you. Yes, any doubts? Anyway, I'll upload this into YouTube. Any doubts, you can post it. You can post me. You can message me. We'll clarify. So thanks for your time, and have a nice day. Thank you.